So welcome back. This is the last part of your lesson on graphing absolute value functions using transformation. Okay. So in this case, we have absolute value of 2x plus 2 minus 3. Now, I know that our first step is to circle things, right, that represent transformation. But when you see a horizontal stretch or compress, or when you see a number that is attached to the x, okay, we're multiplying 2 times x, right? We have a different first step. Okay, we're gonna do the first step as my second step, okay? What we're gonna do is we are going to factor out the 2, pull the 2 out of the 2x. If I pull a 2 out of the 2x, what's left over inside? Now, before you answer, I want you to think about it, okay? Now, who has an answer? What's left over inside? Because it's 2x plus 2, right? That's inside my absolute value. So if I pull out a 2, what's left over inside? X plus 2. Someone said plus 1. I don't know if this is the correct answer. Okay, I just wrote down what you guys said. And the reason why I just wrote it down is because you can check your answer. Okay? So if I plug this 2 back into my equation that I got, x plus 2, I better get 2x plus 2, right? Because we're not changing the value of anything. We're just taking it out and making it look different, right? So 2 times x is 2x, check. 2 times 2 is 4. Wrong, right? I need a 2, but I got a 4, right? So this is not, that's not a 2. What is it? 1, right? So 2 times x is 2x, check. 2 times 1 is 2. Okay? Does that make sense? Yeah, so please check your work if you are having a difficult time with factoring out the coefficient of x. Okay? So now we have this, right? It looks a little bit different, but we're still going to go over and do the first step that we did yesterday, right? And circle or underline or box, whatever you guys want to use, highlight, right? All the transformations. So the 2 does something, the 1 does something, and the 3 does something, right? Okay. So I have 3 transformations here, right? The 2, the 1, and the negative 3. So what does the 2 do? It's inside, answering my questions, right, that we learned last week. It's inside, and we're multiplying. So if it's inside, it's horizontal. If it's multiplying, it's a stretch or compress, correct? Now, if it's horizontal or if it's inside, we have to use our gut. Well, opposite our gut, I mean, right? So if we're multiplying something by 2, would you like your bank account to be multiplied by 2? That means that it's growing, right? That means that we're stretching, correct? We'll go opposite our gut, and now we're compressing. Yeah, opposite of stretch is compress, right? So this is a horizontal compress, DAFO, by a factor of 2. Compressing already makes it smaller, right? So this number here will always be a whole number. It'll never be a fraction, okay? So the fraction is represented already by the compress. It gets smaller because I'm compressing, okay? It'll get bigger because I'm stretching, okay? So So it's a horizontal compressed by a factor of 2. And then what about the 1? What does that do? It's on the inside and we're adding. Answers to my question. Inside, adding. Horizontal, I'm going to put H, shift over to the left or to the right? To the left, 1, right? Think opposite your gut. And then what about the -3? We're subtracting and it's on the outside. Vertical shift down 1 or down 3, right? Okay, so those are my representation of my transformation. Okay, so this one, the first one that we're going to do it via graphing. Okay, so we have this, my parent function, right? And by now, your parent function should come to you fairly simply, right? Fairly easily. Yeah. And that is y equals absolute value of x. Okay. And then my first transformation, I'm horizontally compressing it by a factor of 2. Okay? Horizontally compressing it by a factor of 2. Now, when you horizontally compress or stretch, I need you guys to use your brain. Okay, not math, just brain. If it's a horizontal, we're doing this, right? Compress or stretch. Yeah. We're compressing it. So what happens to my x? Does it get smaller or does it get bigger? It gets smaller, right? Because we're compressing it, correct? Yeah. So my x values changes because it's horizontal. So right now, what I'm going to do is I am going to go into label my x values so I can talk about them. Okay. So if we're horizontally compressing it by a factor of 2, what do I do with those values at -2, -1, 1, and 2? Divide them by 2, right? If I divide them by 2, I make them smaller, right? So I'm going to divide them by 2. So -2 divided by 2, or multiply it by a half, and multiply it by its reciprocal. -2 divided by 2 is -1, so it's right here. -1 divided by 2 is 1/2, -1/2, so right there. 1 times 1/2 is 1/2, so it's right there. And 2 times 1/2 is 1. And 0, 0 will stay at 0, 0. So you guys see the horizontal compress visually by the graph, right? Horizontal compress is the same thing as a vertical stretch. Okay, it has the same effects as a vertical stretch. Okay. All right. So that's my first one. And then I'm going to move this. And we now do this all at the same time. You guys think we can do it all at the same time? Okay. So actually I forgot to label. My purple graph is y equals absolute value of 2x. And then my teal graph is going to be y equals absolute value of 2 times x. Is it -1 plus 1 minus 3? Okay. So I'm going to move each point over to the left 1, down 3. Left 1, down 3. So I'm going to get my vertex over to the 1 and down 3. 1, 2, 3. Right? So that's my new vertex. This, move it over 1, down 3. This one over 1, down 3. Okay, so I have those 3 points here, here, and here, right? Yeah, so far. Shifting, it does mean that every single point, it moves 1 over to the left, down 3. But I don't have to do it over 1, down 3, over 1, down 3, over 1, down 3 every single time. What I can do is I know that the vertex here, if you look at the black graph or even the purple graph, right? The vertex or this, that acts as a mirror, right? So the left-hand side of the mirror is the same as the right-hand side of the mirror, correct? Yeah? The points are exactly 1 unit apart, 1 unit apart, right? Here, 2 units apart, 2 units apart, correct? Yeah, so it acts as a mirror there. And later we're gonna learn the vocabulary for that, but not now, okay? So if I use this line here as my mirror, that's a half unit, so there's my other point. Here's 1 unit, so here's my other point. That make sense? Yeah. So there's my graph there. Cool. And that is y equals absolute value of 2 times x plus 1 minus 3 on the outside. Okay? Questions? What are your questions? Let's move on to the next one. And the next one, I'm gonna change this 9 to 1. Okay. All right. Yeah.
Why do we have to simplify like that?
Why do we have to factor out the x? Because it's on the inside, right? That 2 is essentially being multiplied by everything on the inside. Okay. So when I take it out, I'm literally taking it out and seeing, you see how my horizontal shifting would change? Yeah, that's why. Because that horizontal shift it changes. That's why we have to take it out, right? And see what the horizontal shift is. Yeah. Without getting too deep into the math, that's what it is. Okay. All right. So here we have negative absolute value of 1/3 x plus 1. And I'm going to change this and put it up here. Okay. So here, class, my first step changes, right, from yesterday's lesson. And I see a horizontal stretch or compress. So I am going to take out that 1/3. So that's x. What's left over? X plus 1. Okay. X plus 1. I heard that. So I'm going to check it. Okay. And then there's a -2 on the outside. Right? So if I check it, I'm going to multiply this 1/3 over to the x, which is 1/3 x. Check. 1/3 times 1 is 1/3. Wrong, right? I need a 1. Correct? So it's not 1. What is it? 3. Yeah, I heard a 3. So let's check it again. 1/3 times x, check, is 1/3 x. 1/3 times 3 is 1. Check. Yeah. So please go over that, even if you do not, even though you're sure. Right, you can't be too sure. Okay, so check your factoring. Because if you get the factoring incorrect, class, then everything else from there on out is incorrect.
You never have to multiply, I mean, you never have to divide the X. It's next to it. Like in the absolute value,
Mhm.
when you divide like the one by negative 1/3, or by 1/3, you also never divide the X.
No. No, because if it's 8, so the question was, do I have to divide the 1/3 by X? Right, because 1/3 divided by 1/3 is just 1. Do I have to divide the X? So my answer to that would be 8 times 2 divided by 4. Right? Let's just go back to this math. 8 times 2 is 16 divided by 4, which is 4, right? How else I can get that answer is 4 goes into 8 2 times, right? So you see how I just divided the 4 with the 8, and I went 8 divided by 4 times 2. Yeah. Okay. With division and multiplication, it has the commutative property, meaning that if you divide one number, you're multiplying the other number, right? You're multiplying it by the whole thing anyway. Okay, so because of the commutative property, that's why that works. Yeah. Great question. Okay. So here, I'm gonna go back to my circles. Circle this, circle that, and circle this. Right, so I have 4 in total. The negative on the outside, we already did that a lot yesterday. Hopefully, you guys remember. It's a reflection. Up over my x-axis. The 1/3. Let's use our brain, right? It's a horizontal. I'm just gonna put H. Okay, it's horizontal, so we gotta think opposite, or we gotta go against our gut. We're multiplying, so it's a stretch or compress by 1/3. So it's gonna be a stretch because do we want our bank account to be multiplied by 1/3? Yes or no? No, right? Because it's getting smaller, correct? So since it's compressing, right? Smaller means compressing. Since it's compressing, we gotta go against our gut. It is compressing, so we're stretching. Right? So it's a horizontal stretch. DAFO by a factor of 3. Awesome. Okay, just take the reciprocal of what we're multiplying by. And then the 3 inside addition. Horizontal. Shift to the left 3, right? Instead of going horizontal stretch or horizontal shift left 3, honestly, class, what we can do is just say, okay, it's gonna go arrow pointing to the left 3, and then the -2 on the outside is down 2. Okay, that's shorthand for horizontal shift to the left 3, and then the vertical shift down 2. Okay, does that make sense? Because the arrow already tells me that it's shifting. Question? Okay. All right? Okay, so since we graphed the first one, I'm gonna do the point for this one. Okay, so the first one is a reflection, but before we do the reflection, we have to do our parent function. Right? So y equals absolute value of x. So x, y is -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And then we go to y equals negative absolute value of x, right? Okay, so if it's negative absolute value of x, what changes? The x or the y? The y's would change, so I'm literally going to copy and paste with my chart the x values. Okay? Yeah, literally copy and paste. Right? Because my x's aren't affected at all. But my y's are. What am I going to do to the y if it's a reflection over the x-axis? Yeah, put a negative on it, right? Or multiply it by a -1, or just switch up the signs. So I see a +2 turns into a -2, +1 turns into -1, 0, -1, -2. Right? Changing the signs. If it's positive, it's negative. If it's negative, it's positive. Okay? My next one is a horizontal stretch by a factor of 3. Actually, before I do that, I'm going to graph this. 0, 0, 1, 1, 2, 2, -1, negative, -1, 1, -2, 2. That's my parent function, right? In purple, -2, -2, -1, -1. So -2, -2, -1, -1, 0, 0. And if I use my mirror, it's right there and right there. Or you can go ahead and look at the points as well and get those values, right? Okay, in blue, it's going to be a horizontal stretch by a factor of 3. So that's y equals negative absolute value of 1/3 x. Okay. Now, if it's a horizontal stretch by a factor of 3, what's going on with my y? Or what's changing, my x or my y's? Huh? If it's a horizontal stretch, my x's or my y's? My x's are changing, right? So I'm going to copy and paste my y values. Okay? So y is -2, -1, 0, -1, -2. What's going on with my x's? It's a horizontal stretch by a factor of 3, right? So if I'm stretching it horizontally, look at the fist, right? It's near my face. Yeah, if I'm stretching it, this is a stretch, right? If I'm extending my arms out. Is my x values growing or are they getting smaller? Growing. So if it's growing by a factor of 3, what do I do with the x's? Multiply by 3, right? So -2 times 3 is -6. -1 times 3 is -3. 0 times 3 is still 0. 1 times 3 is 3. 2 times 3 is 6. Make sense? Yeah. So -6, -2. Right here. And this one, the mirror would tell me 2, 4, 6. This one. 0, 0. And then I have -3, -1. And I have 3, -1. right? So we see the horizontal stretch, right? We see it, correct? So so these 2 points were here, right, and stretched out. Yeah. So these 2 points were here, and it went all the way over here, so it kind of stretched out to here, right? So you see the stretch, right? Now, if we compare the purple to the blue, and if I ask you, hey, what transformation is this? If it starts with vertical, if my transformation starts with vertical something, what would it be? From the purple to the blue. It would be a vertical. Huh? What are we doing vertically? So to help you out, this point and this point turn to this point and this point, right? It's not on the graph because I didn't graph it, because this is a horizontal compress or horizontal stretch. But what do you do vertically? We compressed it vertically, right? It went smaller vertically, correct? So a horizontal stretch is exactly a vertical compress. Okay? Okay, but just with different points. All right? And that's the difference. Okay? And now after that, we're gonna move this over to the left 3 and down 2. Class, are we up to doing these 2 guys together? Left 3 down 2, right? So left 3 down 2, left 3 down 2. And I'm just repeating myself so I know what it is. 1/3 x plus 1 down 2. Okay. So here, if I'm moving to the left 3 down 2, I'm not gonna write it here. Left 3 down 2, right? What's changing? What's changing if it's left 3 down 2? X and Y, right? So both of them. So there is no copy and paste here. Okay, I said there is no copy and paste, but I'm gonna copy and paste this. That's so that I can see it side by side. Okay. So there's my old points, right? So my X value, what are my X value doing if I go to the left 3? Subtracting 3. So -6. So let's do it. -6 minus 3 is -9. -3 minus 3 is -6. 0 minus 3 is -3. 3 minus 3 is 0. 6 minus 3 is 3, right? What am I doing to the y's if I'm going down 2? What am I doing if I'm going down 2? Subtracting 2, right? Okay, so -2 minus 2 is -4. -1 minus 2 is -3. 0 minus 2 is -2. -1 minus 2 is -3. -2 minus 2 is -4. And class, I'm not going to show you the graph on it because I ran out of graph paper. Okay, it's going to go off of my graph paper. Okay, but as long as you graph these points on your graph afterwards, you should be good. Questions? What are your questions? If you're asked to graph. On the assessment, I'm gonna be very specific on what I want. Okay, sometimes I will want the points, just the points. Sometimes I just want the graph. Sometimes I want both. Yeah. But I'll tell you this, you're always gonna label your transformation. You're always gonna do the steps above, it, right? Where it's horizontal stretching by a factor of 3 or whatever it is. Yeah, you're always gonna write out the description. Okay? Any other questions? That's your lesson for 2.1 on graphing absolute value functions with transformations. Okay? Thank you.